Good morning, everybody.
Good morning.
Morning.
Happy Friday.
And happy Friday.
Finally here.
I know.
The days don't really seem to make much of a difference. It is Friday.
Yeah, that's true.
But it's going to be a short lesson today. I just want to go over one thing really and go through a few demonstrations.
Okay.
So the main thing I wanted to do is show you, okay, so this equation we talked about yesterday, actually, where it's delta U equals Q minus W. And we said yesterday that delta U is the internal energy. So if you increase the energy of the system, you'll have an increase in temperature. So with a positive delta U, temperature will increase. With a negative delta U, temperature decreases. And we talked yesterday about a few ways that you can make U positive or negative. So Q represents the heat you add to the system, and then W is the work. Now, if it's the work that the object does on the surroundings, but you can do work on the object and make this become positive. So the work you do on the object would be a negative W times a negative, becoming a positive. So if you do work on an object, you will in effect make this positive W. You will be adding to delta U and making it increase. Does that make sense?
Yeah, so basically, like, if the object is doing work, work is, like, going from the object, and that's why it's negative. But if
Very
it's
good.
okay.
Yeah, exactly right. And if the object does work, it loses energy and it cools down. If you do work on the object heats up. So to demonstrate that, I want to show you a few examples. Let me get my computer moved so you can see this. Just give me 1 second. And let me move this whiteboard off so you can see this better. I've used Zoom for 6 weeks and I still forget how to do this.
I know, for real.
Okay, can you see? Okay, so the first thing I'm going to show you is, so I have a cup of hot tea, like I always do. And if you put your hands around a cup of hot tea, I'm not doing any work. I'm not moving my hands. But the heat from the tea going into my hands, you see they're red. It's pretty hot. So the heat has flowed from the cup of water to my hands. And that's Q. And so Q has been added to my hands. Increase in Q, increase in U means increase in temperature. My hands get hot. So that's one way I can increase thermal energy in my hands, is by having heat flow from something hotter to my hands. And that's how you increase Q. To increase W and do work, I could clap my hands. And as I clap my hands will warm up too. They also will turn red and get hot. I'm doing work. And by doing work on my hands, I'm heating them up. The temperature in my hands is the same on both sides. I'm not adding heat to my hands. And the surroundings is cooler than my hands. So I'm only heating up because I've done work on my hands. That's one example to use to apply that equation we just talked about. Another thing to think about is this. I have a paperclip right here, and I could bend it back and forth. And as I do that, I'll be heating up this area right here. Now, it's not going to be a dramatic change in temperature, but it will heat up if I bend it back and forth. I'm doing work with a paperclip, I'm giving it energy, it heats up. If you hammer a nail, the nail and the wood get really hot for the same reason. You're doing work on the hammer and the nail, it heats up. So that's how I can use work to heat it up. I can also apply heat. I could get a lighter. I can turn this on. And I'm applying heat now. And so in this case, I'm not doing work, I'm not moving it, but I am applying heat, I'm applying Q. And so by increasing Q, I've increased delta U, I've increased its temperature. So those are a few examples of ways that you can increase either Q or W and increase the temperature of the material. Get this back on here. Okay, I had a few other demonstrations today, but I don't have my supplies with me, they're in my classroom. So I'll have to do that on Monday for you all. So for today, it'll be a pretty short class because I don't have my supplies I need for the other experiments I wanted to do with you. But I did want to go over one other thing. I realized the other day think it was 2 days ago, we talked about this equation where it was Q equals mass times heat of fusion. And we use that, and we use Q equals MCAT. And I think I said for this one that you get kilojoules for that. And for this one, I think I said joules. But that's not right though, if I said that. See right here in your book, if you look it up on the table on page 318, you're gonna see the units are joules over kilograms times Kelvin. And so this will actually give you joules and not kilojoules. Same thing for this one. If you look that up in your book, it's 336,000 about joules over kilograms. So both of these, because they have joules in their unit, will give you joules for your answer. So just to clear it up, I don't know if I said that for everything or just for one example, but just to make sure you all know, the unit will tell you what you get at the end, and you get joules for both of these. You don't have to convert it to kilojoules. It just stays in joules.
Okay, thank you.
Did I clear it up?
Yeah.
Okay. Are there any questions about the homework yesterday? That one was a little bit confusing, I think. But did that make sense to everybody? Okay. Let me show you a short video before we end today. This is an experiment I wanted to do in class with you all, but we didn't get a chance to. But next year, we'll get to do this. Okay, it gets pretty dramatic in there, but I just wanted to show you what happens when, every year we do this as a class, but we didn't get a chance to do it this year. But next year we'll do that. That's it for today, because I don't have any other experiments that I can do with you all, but on Monday we'll do more demonstrations. Any questions about what you went through in either the quiz or the homework before we leave?
No.
Well, have a good weekend. I'll see you on Monday.
Thank
Okay.
you.
Thanks, Miss Holly.
You're welcome.